Okay, all right. So, brief us about yourself.
Okay. First of all, thank you for your time. I am Lakshmi. I have in total 9 years of IT experience, out of which 3 years is on big data. And initially, I did BCA and MSc Computer Science from Andhra University. And
Mm-hmm.
initially, I started my career in Java. And I worked on
Mm-hmm.
Java for overall 7 years. Then I moved to big data. And now currently, I am working. Uh, Primarily on PySpark, Hive, Kafka, HBase, Scoop, like these technologies.
All right. So, what's your background of education?
I did bachelor's in computer science and master's in computer science from Andhra University.
Well, all right. Can you please explain your previous experience or with your past companies?
Yeah, my past project includes gathering data from a e-commerce website in which we will analyze the clickstream data and we will analyze how much time each customer is spending on what page or on what product he is spending, and we will send some relevant offers regarding his point of interest, and we
Okay.
will also try to answer the queries sent by the customer, and
Mm-hmm.
we will formulate some message in the form of a reply, as well as we will also send the offer messages to him in the form of text messages or emails.
Mm-hmm.
So this is about my
So,
past project.
okay. So, what's your role in that? What you are, I mean, you are doing in your project?
Yeah, my role in this project is to gather the clickstream data by applying some transformations, and I need to extract the time he is spending on that web page and the product on which he is spending the time, and pull his old information and and formulate some messages and send them.
Okay. So, what type of source data it is? Like structured data, semi-structured data, unstructured data? What type of
It is
data?
it is completely structured data. We will get it in the form of CSV files, and the source from which we will get it is a Kafka source, and my PySpark application is the receiving thing, and we will first store this data in the HDFS and extract this data and again apply some business logic and transformations on this.
Okay. So, you said the data is coming from which environment? Like, is it again big data, or is it from RDBMS system, or is it some like weblogs kind of thing?
It is from the website. They will be having some program to receive that clickstream data in the with the help of a data, and they will store the data in a database. And from that database, we will be receiving with the help of our Kafka producer.
Okay. So you are aware of Kafka as well.
Yeah, yeah. To some extent, I'm aware of it.
So what exactly difference between Kafka and Flume or Scoop?
Kafka is a publish subscribe messaging system. It is a set of servers which acts as a mediator of receiving the data and sending the data to the customer, while Scoop is a tool which acts as a mediator between RDBMS and HDFS. Means we can extract from a database, we can import and export data from a database to HDFS. This is the main purpose of Scoop. And Kafka is a thing, it is not limited to RDBMS or something. It can receive from anything, and it can also send to any customer.
Flume also will do the similar thing, right?
Okay. Mm-hmm.
So which one I have to use and when I have to use?
Okay. If you don't need any fault tolerance, or if you want to send data from one in the form of a queue, like one person is sending, and that particular data is received by another person, not by multiple people. So in this process, you can use Scoop. But for Kafka, this is a system which is very robust, fault tolerant, and it maintains multiple servers and a zookeeper for recovering from the failures. It also maintains the replication of the data in the servers, and this is more robust and highly high throughput is achieved through Kafka, and this is distributed also, Kafka. In contrast, I can say that Scoop is a tool which can be used for one particular type of data flow, but Kafka is a tool with lot of power with it, means fault tolerance, multiple input and multiple output. So Kafka is more robust and reliable, and it is very fast.
Okay.
That's what.
In your project, you are using Kafka, right?
Yeah.
So, in general, let us say we have source and target systems, right? So,
Mm-hmm.
by using Kafka, we will pull the data from source system and we'll try to write the data on target, right?
Yeah. Mm-hmm.
So, let us say the target system is not that much fast where we are pulling. Like, let us say per minute we are pulling, let us say 1,000 records. Okay.
Mm-hmm.
So if I'm unable to write those 1,000 records into target table, then how
Mm-hmm.
Kafka will handle in that case? Shall I miss something? Will it write only let's say 500 records per minute, and it will lose the remaining 500 records, or how it will manage?
Kafka has the power to resend the data. When we request, when we sense some loss of data, we can again request that particular data, uh, and it can resend the data for us. So in this way, we can avoid the loss of data.
You mean, internally, what exactly the structure this Kafka maintain so that it can retain the excess data and again send it back to target table. I mean target system.
Kafka is not a single server. It is made up of a group of Kafka brokers. These servers are called as brokers. In that, data replication will happen, like each data is partitioned and replicated 3 times, and one partition is selected as a lead partition, and this partition is the main thing which will be sent to the customer. And in case of loss of data, we have to specify the particular partition and the topic name which we want. Then it will pick the data from the replicated partitions and send us back the lost data.
Okay, so you're saying as and when you receive data on Hadoop, right? Your data, I mean Kafka write data on Hadoop environment, right? Or you're using any cloud environment like
Hadoop
Amazon S3, like
environment. Hadoop
that.
environment.
What is the Hadoop version that you are using?
Hadoop version is 2.7.0.
Version of a Spark that you are using presently?
It is 2.4.6.
Mhm. Is there any reason why we are using 2.4.6? Because now the latest version is 3x, right? So
Yeah.
why still you are using 2.4.6 instead of 3 version?
It is organization's decision. I don't have any specific reason for that.
All right. So, okay. Hadoop 2.7 version and Spark 2.4.6, right?
Mm-hmm. Yeah.
In your application, What about tables that you generally create?
In my application, I generally create the Hive external tables. Yeah, we will be accessing those tables through my Spark application and apply some transformations.
Okay. Why you have chosen or your organization chosen to create external tables instead internal tables?
Usually, they don't want to disturb the data whenever we drop the table. That is the main reason they want to use the external table. They want to use the data for multiple purposes, not only for my application. They may need for some other purposes. So they don't want to delete the data accidentally or purposefully or whatever. They want to store the data safe, but they don't want the table. So in this use case, they are using the external table.
By default, when we create a table and load the data,
Mhm.
where our data will be stored under Hive.
If we specify some path for the external table, it will be stored in that separate path. And if we don't specify any path while creating the external table, this will be the default folder where we have to store the data, where the data will be stored.
Can I create an internal table with different path?
Yeah, we can create with a different path.
Mhm. So when we create a table, right, where exactly this metadata will be stored?
Uh, High metadata is stored in a separate database. Mostly by default, it is a Derby database. In
But
that,
in
it will
real
be
time, we don't use, right? We don't use it, right? A W database won't be, useful, right? So definitely we
Derby.
might have the different database where,
Yeah,
all Hive metadata will be stored.
yeah. We were using an SQL database. Yeah, we were storing in the SQL database.
Why should we use SQL? Why don't we, why don't we can store this metadata in Hadoop?
Um,
You got my point, right?
yeah.
See, when we are creating a table,
Mm-hmm.
obviously metadata will be created. And
Mm-hmm.
when we store the data, all the data is getting stored in Hadoop environment. In other words, HDFS, right?
Mm-hmm.
But
Mm-hmm.
why this metadata we are storing on my RDBMS system or MySQL system?
I'm not sure about this.
All right, no problem. Uh, so, what type of file formats you generally worked on?
I worked on CSV, text, and Parky file formats.
Mhm. What exactly the difference between CSV and Parquet? Why should we use Parquet or where should we use Parquet and where should we use CSV or text file?
Okay. CSV is a comma separated file format in which it is it saves completely structured data, and Parky is a particular thing for Spark. Means Spark works with the high capacity when the file format is Sparky, because Spark is a default file format for Spark, and it is a column oriented storage, and compression of this kind of file format is very easy, and data can be compressed, highly compressed with Sparky. And it also uses vectorized reader, which is lacking in the CSV file format. Vectorized reader means it allows us to read a bunch of rows in one read, and thus it improves the fastness of reading. But in CSV, this compression and the vectorized reader, these two are lacking in the CSV file format. And it is always advised to use this Parquet file format for these kind of advantages.
So in your application, which file format you generally used? I mean, is it CSV or Parquet or ORC, etc.?
I was using CSV.
So what you are saying, Parquet will have better compression than the CSV, right? Why you are choosing CSV instead Parquet?
The data we are dealing is a completely structured data, and they just chose like that to use a CSV file format.
Acha. Okay. So what is the size of the data, in general, that you deals per day?
Per day, I will be receiving some 100 or 200 tables of data, and each table will be either 1 GB or 2 GB. So approximately, I will be receiving like 200 GB of data.
Okay. So how much time it will it take to load that much of data for you?
It usually takes like a few hours of like 3 or 4 hours.
So, like how you automated your system? Like, what is the scheduler? Like in Hadoop, we can say Uzi is a scheduler, and there is a Airflow, and there is a Redwood with
Yeah,
Talent. So, like
we
that, we
were
have some schedulers. So, what
mhm.
type of schedulers that you generally use in your project?
We were using the Airflow. The members of our team were using the Airflow scheduler for scheduling the tasks.
Okay. So, how comfortable you are at Airflow?
I'm not much into it.
Can you please tell me? I think you might have complete, overview of your project, right? How exactly from where it is starting and from to where it is going, and
Mm-hmm.
I mean, is the final output is going to the different client or third party, or will it going to to visualization tools, etc., or how exactly it is? Can you please brief me, high level?
Okay, our output data will be stored in HDFS, and other teams, data analytics teams, will be using some BI tools like Power BI or Tableau to visualize those things.
Do you aware of performance tuning in Hive?
Yeah,
Can you please tell me what type of performance tuning that you have done in your project?
okay. In Hive, we will be enabling the vectorization in Hive for getting good performance, and we will be also using the ORC file format, and we will be using only the map side joins.
Can you please brief me about what is map side join?
Map side join in Hive is similar to a broadcast join in Spark, which is nothing but for example, if you have a small set of data and a big set of data, both of which you need to join, and instead of sending the whole data to every node, we will send a read-only copy to this uh, to every node for performing the join operation. This greatly reduces the main shuffling, and it performs the join in a faster mode. So this is this is the map set join of Hive, which doesn't involve the reducer.
Okay, all right. So, is there anything else that you can also do for performance tuning? I think you may cover a few more.
Okay. Partitioning the data properly, the proper partitioning and bucketing of data.
Gotcha. So how many columns generally in your application does?
Generally, we'll be getting some 50 to 80 columns of data.
Mhm. And of course, okay, what type of data it is like? Is it incremental load or is it full load? You generally do.
We are dealing with the incremental load.
All are incremental load.
Some are incremental and some are real-time streaming load.
Mhm. How many total of tables approximately you have in your Hadoop environment? Do you remember?
I'm not sure about it.
Achha. Okay. All right. Coming to Spark, right? So, what exactly the difference between RDD dataset and data frame?
Okay. RDD is a basic data structure of Spark, and it is a fault tolerant and distributed data. RDD stands for Resilient Distributed Data Set, and it is fault tolerant and distributed. It deals with structured and unstructured data, and it cannot avail the optimization techniques of Spark, like Catalyst Optimizer or Tungsten. And it is the object of RDD is similar to any object oriented programming object, and it uses Java serialization. And whenever you deal with some low level transformations, you have to use RDDs. While coming to data frame is exactly similar to a table in any database with named columns. And RDD cannot infer schema. We have to specify the schema explicitly. But data frame can infer schema by itself, and it can be used to process structured and semi-structured data. And it is very easy to use. Data frame is a very good API, and it is very easy to use as we have data in the form of a table and we can access the columns. And it can use it is faster than RDD. It uses Spark's cryo serialization. And coming to the data set, it is a combination of RDD and data frame. It acquires the features of the object-oriented features of the RDD, and it is also type safe. And dataset can also handle structured and unstructured data. Yeah, this is the differences.
Okay. So, in your applications, right? So, what exactly, like, which one you use more? Like, is it RDD or data frame or dataset? Which one
Data,
you are using more?
I was using the data frames.
Okay. So when you are using data frame, right? So definitely we should create a Spark session, right?
Yeah.
Why should we use or why should we write Spark session first?
Spark session is a key point from which we will access the resources of the cluster. Driver program is the main program, but driver in turn creates the Spark context, and Spark session. Mm, the question is why we will use the Spark session, right?
Correct. Why should we use Spark session?
Okay, Spark session is a unified entry point for all the APIs. There is no need to separately use any separate HiveQL or separate context for the SQL or HiveQL or the machine language. Everything is embedded in the Spark session. That's why we'll use the Spark session.
I think, do you have a Spark context as well?
Yeah.
So what exactly the difference between a Spark context and Spark session?
Before Spark 2.0, Spark Contest is the entry point for any Spark application, and it required a separate configuration to be specified to be combined with the Spark context. And with the Spark context, we need to create, whenever we want to use SQL, we have to create another separate SQL context. And if you want to use Access Hive, we have to separately create a Hive context, or any other machine learning thing, we have to separately create other context. But from Spark 2.0, Spark session arrived, and this is a unified thing. With Spark session, we no need to separately uh, uh, create different sessions for Hive or SQL or any other machine learning things. With this single point, we can access all these things. And Spark session allows a user to separately configure his own configurations for each user. But this was not the case with the Spark context. In Spark context, all users were sharing only one configuration, and Spark session allows each user to configure his own thing. And this is the biggest advantage of Spark session.
Okay, I will tell you one scenario. Let us say I have a Hive table. Okay,
Mm-hmm.
so in that, let us say we have some record. Let us say 100 records. Okay, I
Mm-hmm.
want to create a data frame out of it and process the data. Okay,
Mm-hmm.
so can you please give me the syntax? How you will start exactly? Let us say my table is there in Hive, and
Mm-hmm.
anyway you are working Hadoop with Spark, right?
Mm-hmm.
So how can you create a data frame out of it?
First of all, in order to access a Hive table, we have to enable Hive support in the while creating the Spark session object. Spark session.builder.appname.enable Hive support true, we have to mention. Then we can directly access the Spark table using the HiveQL select star from the database dot table name, and Spark dot SQL dot this SQL Hive table accessing, and we will in turn put it in the data frame.
So let us say you said we can connect to Hive and we can do some queries over it. You're saying that.
Yeah, yeah, yeah.
How can I save that output? Or let us say we have used some queries and out of it we got some output. Then I want to store that output again back to HDFS in the form of let us say table. Okay.
Mm-hmm.
We retrieved data from two, three tables, source tables, and finally we did some transformation on it, and
Mm-hmm.
we got some output data. That
Mm-hmm.
output result, I want to store in a some JSON format in a table. Okay, so how can you do
Mm-hmm.
that by using Spark and Hadoop?
There is an API called a save as table. Using that API, we can just specify the path in which you want to save, and you can save it as a table. Uh, okay, you want me to write in a JSON file?
Yes, I want to JSON. I want to the file. I mean backend in a table, right? Backend should be
Okay.
stored as JSON.
Okay. Then spark dot write dot option format is equal to JSON, and and the path, specify the path.
Mhm. Okay, all right. So what is encoder?
Uh, encoder.
Yeah.
Encoder is something that deals with the data sets. It is one of the optimization engine, and it deals with um, no, I'm not getting this now as of now. I couldn't recollect about it.
So what type of issues that you have faced when we are working with when you are working with Spark with Hadoop, right? So
Yeah.
what type of practical problems that you have faced and how you have fixed it?
Uh, the most common problem is yarn container retention error. Means most of the time we won't get the, whenever we are deploying our code just before the deadline, everybody will be needing the cluster, and the resources we request will not be could not be provided by the yarn because everybody is using the cluster. So that is the main thing we faced, and to avoid it, we will be just running our code one day before or after, or in a less traffic window. And another issue I found is most of the time the executor will run out of the memory, and the problem is with the data, some unevenly partitioned data, or dealing with the big amount of data which is not fitting in the executor memory. And sometimes we'll get the driver out of memory errors, because I was trying to get the whole big file into the driver memory. So I need to avoid all those. Instead of getting the whole data, I need to get some small part of data to avoid this kind of errors in driver. So these are the errors I faced.
Let us say I have a 10 GB file, okay? So,
Mm-hmm.
but in our cluster, the availability is only 5 GB, okay,
Mm-hmm.
memory, okay?
Mm-hmm.
So, how can you deal this? I don't want to wait, as in queue, but let us say I want, it should be executed in an hour or let us say 2 hours, okay?
Mm-hmm.
If you have 10 GB of memory in your cluster, then it is sufficient to execute this application, whatever that we are trying to execute it. Okay, but you
Mm-hmm.
have only 5 GB of memory is left, and you have
Mm-hmm.
more disk space available. And if I
Mm-hmm.
give you instead of 5 hours, let us say take 10 hours, and you should complete it with this 5 GB only, 5 GB of memory only. How can you do that?
Mm-hmm. First of all, I'll put the persist level to memory and disk, and I'll try to execute this job. As I have less amount of memory, and my file is bigger than the memory, I need to spill this file to disk whenever it's needed. So I will use the proper persistent level like memory and disk, and run this.
Who will take care of this? Like once we declare persist in memory and disk, then we have to manage the data, or who can internally can manage it? Either in Yarn can manage it, or Spark Manager can manage. Which one? Who will manage this?
Yeah, Spark manages this thing.
Then what Yarn can do here?
Yarn is a resource manager which will grant the resources how much we request.
You said you are using Spark, right? So when you write a program, so how you submit it, or have you placed your file into in your project? Like how it exactly you apply the code?
Mhm. First of all, I will copy my code to the dummy node. Then I will put the Spark submit command along with this specifying the path to my files, and specifying the resources like number of executors, number of threads, driver memory, executor memory, everything will be specified there. Then I will run the Spark submit command there.
Okay.
And I will also
So,
mention the
yeah.
deployment mode.
Yeah. Is there anything else that you pass when you are submitting your Spark submit command?
Yeah, what is the resource manager? What we will have to mention the resource manager.
Mm-hmm. Anything else?
Yeah, these are all the things.
Acha. Okay. All right. So, which language that you are using to do all these things along with the Spark and Hadoop?
I was using Python.
Acha. So, in Python, right? Let us say we have some dictionary. Okay, dictionary is having, let us say, some fruit names. Okay.
Mm-hmm.
So, how can you, print that names are on console? Can you please tell me the pseudocode?
Printing the names.
You understood, right? Let us say dictionary is having like orange or
Mm-hmm.
apple.
Mm-hmm.
Some fruits are there. So the
Mm-hmm.
same thing, I want to see on the console. Okay, how can you sort it? How can you print it?
We have to access the key of the dictionary, and when we access the key, automatically the value of the key will be printed.
Okay. So can you please give me the pseudocode? Is it possible to tell
Okay.
the pseudocode to write the same?
Okay. So, for example, you said a fruit, apple. Then again, I will go for animal, some tiger. Then I will
Mhm.
access the, for example, the name of the dictionary is DIC1 of
Okay.
fruit. I'll just display that one. Then DIC1 dot 1 of animal, and I will print the value of those things.
Okay. All right. So, do you aware the difference between any and all?
Any and or
All.
all. Okay, okay. Yeah, I was using those things in removing the duplicates or removing the null values.
Hmm.
Yeah. Okay. Any means, for example, I want to remove a row in which any of the column is null. Then I will give an option like a data frame dot na dot drop. In the parenthesis, I will give any. If I give any, if one of the column is null, also that row will be dropped. And if I give an option like all, whenever the all columns are null, that column will be dropped.
Okay, can you please differentiate between generator and iterator in Python?
Generator. I know iterator, but I'm not that clear in this topic.
What exactly the difference between list and array?
Okay, a list and an array.
Mhm.
List is an advanced data structure of Python, while array is a traditional data type which can be found in any kind of language. And list is heterogeneous, means it can accept multiple data types inside it, like integer, string, double, float, any kind of data type will be in between the parentheses of a list. But an array is something which accepts only one kind of data type. It is not heterogeneous. And list is mutable, and array is immutable. Yeah, these are the differences I can say.
Okay, so can we able to convert a list into tuple?
Yeah, we can convert
How can we convert?
by using tuple and parenthesis and provide the list in the parenthesis.
Okay, so okay, so what is the major difference between tuple and list?
List and tuple are almost same. Only thing is list is mutable and tuple is immutable. And list takes a square parenthesis, tuple takes half circle like parenthesis.
So I think you are aware of about a lambda function in Python, right?
Yeah.
Can you please give me an example how it is useful?
Okay. Lambda functions I was using while processing the RDDs while implementing the map functions or filter functions in RDDs. Lambda is an anonymous function which takes only one line of code. It can accept any number of parameters as arguments, but only in one line of code this function will be done. And for example, I define a function like x is equal to some lambda of x and x plus 1, and I can use this x and pass some parameters in that, and that lambda function statement like x plus 1 will come out as a result of this call.
All right. So did you work on X range in Python? X range function in Python?
uh, X range, no.
How you have utilized Python language in Spark?
Using the data frames,
Okay.
lists, and using the range function, using the drop na functions
Mhm.
or fill na functions, and and the loops.
Yeah, that's fine. So can you please tell me what is the difference between map and flat map in Spark?
Map and flat map, yeah. Okay. Map is a function that takes one parameter as an input and gives one parameter as an output. It is a function which operates on each and every element of a data frame. And flat map is a function which takes one parameter as an input and it can give more than one parameter as an output. For example, I have a list which contains some three subsets of lists, like list 1 to 3 is another subset of list, and 3 4 5 is another subset of list, and 4 5 6 is another small list inside the bigger list. If I apply a map function, the structure of this list will come out as the same and the output may change, the data may change. But when I apply a flat map on this, the sub lists whatever I specified, they will not be there inside the output. The whole data will come out as one list when I apply a flat map on a data frame.
All right. Okay. I think I'm done. So you have any questions?
And no.